Then, if no problems, then I will start my teaching, okay, and collect the homework, okay. So, exercise 1A, any issues regarding question 5, if you have, you raise your hand, okay, then I'll go through those questions. Question 6, any problems? 7, 8, no issues with exercise 1A, alright. Next, we look at exercise 1B. Okay, I hope that you also take the opportunity when you're doing homework to check your final answer with the answer key at the back of your textbook. Okay. Exercise 1B, question 4, any problem? Question 6. Question 8. Question 10B. How about 10D? No issues also. Okay. How about exercise 1C? Question 7, 9, question 9 issues, question 11, 11 no issues. Okay, so that means this series of homework, they're all okay, huh? Okay, then could you please submit your homework to the front, okay? Maybe just to facilitate the collection of homework. Okay, this cluster of people you submit to the front like that, this cluster submit to the front. The row at the back, maybe you submit to Jasper and then collect from Jasper. Okay, because there are 3 pieces of homework, the people at the front help me just to separate out to 3 different sets. Jasper definitely cannot handle, so please help him out. Likewise, the people at the front. Okay, please help me collect and then put them out into a different pile. Yes. Yes, I said separate different exercise. Did you all do it in the common exercise? If you all did, then just submit that one. Okay, put it with the exercise 1A. I'll figure it out when I mark.
Keep star. Nobody said anything that time when I said so what. Yeah, I'm not way too late. The reason is because so that I mark the exercise easier for me to finish through the whole thing. Yeah, that was one of the reasons. But actually I'm okay with you all putting together. Yeah, but definitely no problems. Yeah. I don't like it. Okay, done. Then here got 5, 4, 4. So 4, 8, 12, 15. Okay, 4, 8, 12, 13, sorry. Because sometimes people will write in 1A. Yeah, my sometimes you do 1A, never mind, you give me 1A first. This is the everything together one, never mind, 1A together. Okay, B, C, thank you.
Okay, other than Jovia, is there anyone who has not submitted the homework? Sorry, your name is? Sorry, I can't catch the boy's name. Beside Renyi, yes. Your name is? Ziyue, okay. All exercise not submitted, is it, Ziyue? Cannot hear you at all. What do you say? That means you can get it up by today. Please have my longer number for tertiary, alright? Okay. The rest of us, could you take out your worksheet, please? On set. Alright, let's start. Are we ready to start? Ready? Still waiting. Okay, in the last lesson, we were looking at this investigation activity which I extracted out from the textbook. Okay, is it bright in the front? Do I need to switch off the front lights? Okay. So, that last lesson, right, we have covered the 3 different possibilities of drawing the Venn diagram for this particular situation, whereby you have the number of elements in the universal set, in set A and as well as set B. Okay. In general, we will look into 3 different kind of options: either the proper subset situation, the overlapping situation, otherwise the disjoint situation. Okay. This will actually help us in identifying when is there the largest and the smallest number of elements for the intersection as well as the union. So looking at question 2 part I, right, okay, and based on our Venn diagram, okay, we want to find out when is it that the number of elements for A intersect B is the largest. Okay, so it cannot possibly be the disjoint set because the intersection will actually be empty. So we're looking at either this or this situation. Very clearly from the Venn diagram itself, I can see that the number of elements, okay, in the intersection is 2 over here and 1 in this case. So the largest value, okay, is actually 2, and that is happening when B is a proper subset of A. Okay. So likewise, going down the list, the number of elements where A union B is the smallest, okay, when is it that it happens and what is that actually going to be? So looking at the situation for A union B, we want the smallest one, that means on the outside, we want a bigger number lah. Okay, and that happens when it is proper subset. The union in here is actually 3 elements, whereas the union over here is 2 plus 1 plus 1, that's 4. Over here is actually 5. So the smallest occurs over here when B is a proper subset of A, and the smallest value is actually 3. Okay. elements of A intersect B, it is the smallest, okay, when what? Let's see, Chloe Yo. I'm terribly sorry if I still cannot recognize who is this person. Chloe, is it you? No, it's there. Okay, yes. When is it that our number of elements of A intersect B is the smallest? Okay, when the two sets are disjoint. We usually don't say B disjoint C or D disjoint A lah, okay? So it is when your A intersect B, okay, A intersect B is a empty set. Okay, in other words, this is describing a disjoint situation lah. Okay, and that is when the number of elements is 0. And then the number of elements for A union B is actually the largest when what? When Tijan tells me the answer. Next Tijan. Yes. When is it? Say again. When do we have the number of elements of A union B being the largest? That means both sets add up together is the largest number. A intersect B, you don't know the answer, okay? So if we fall back onto our Venn diagram here, right? Okay, we look at the different situation. A union B, oops. A union B is when the two sets, okay, the numbers, they add up to be the largest. Okay, so this will give us a value of 3. This gives me a value of 4. This gives me a value of 5 when I add the two numbers up. Okay, so A union B is the largest in this situation. This situation is the disjoint situation, which is where A intersect B is empty. Okay, and the largest value is actually 5. Questions? Moving on. This one. Okay. So in this particular case, hope you can see from your own worksheet, we are given that the number of elements for the universal set is 6. For number of elements in A is 4, and that in B is 3. Okay, we want to draw Venn diagrams to show all the ways in which the sets can be related, okay, indicating clearly the number of elements in each region. Okay, so let's do the simplest one first. I believe the simplest one is to see whether they can be proper subsets or not. Okay, it is possible in this case because one number is smaller than the other. Okay, if one number is smaller than the other, then naturally there is that possibility for proper subsets to occur. Okay, and that is where B is inside and A is outside. It cannot be the other way around. Okay, and then the rectangle will be your universal set. Then we fill in the numbers. So B will have to be number of elements of 3. This area will have to be 1. Because 4 minus 3 is 1. Okay. This add up to be 4 already. But the universal set has number of elements of 6. That means that on the outside, okay, will have to be 2. Okay. Right. So the proper subset situation is done. Okay. Let's look at the other extreme end, which is to look at disjoint situation. Okay. For disjoint situation, that means our two circles are separate. Okay, we have A and B looking like this. Alright? Sorry, very ugly with this side. Okay, but you see, in the disjoint situation, right? Okay, the number of elements in A has to be 4, number of elements in B has to be 3. But 4 plus 3 adds up to be 7. This already exceeds the number of elements in universal set to be 6. So, is there ever that possibility for it to be disjoint? No, right? Okay. So therefore, in this particular situation, this is not possible. Okay, since number of elements in A plus number of elements in B is more than the number of elements in the universal set. Okay, so now we will look at the overlap situation. Okay, so overlap. Let's just draw 2 circles that overlap first. Okay, we always determine the number of elements in the overlap area first. Okay, so because A has 4 and then B has 3, right? Let's start with the least, which is 1. Okay, it cannot be 0, because 0 means it's disjoint already. We know that it's not possible anymore. So start with 1. Okay, if there's 1 over here, the number of elements in B would be actually 3 minus 1, that's 2 over here. And the number of elements in A but not in B will be 4 minus 1, that will be 3. So this is one situation. Okay. But is this the only way that you can overlap? We have another case of overlapping. It is possible, right? Because overlap of one element, the maximum it can overlap is 3. There is that possibility of overlapping of 2. Agree? Okay? Because the maximum is 3 for the overlap, such that it becomes a proper subset situation. Okay? So that's why when it comes to drawing our Venn diagram, we go for the extreme situation. Overlap of everything, which is our proper subset, or overlap of nothing, which is your disjoint sets. Then we slowly calibrate to determine how many elements are there in the intersection. So in this case, there are 2. That means that the number of elements in B but not in A will actually be 1 over here. And in A, not in B, will actually be 4 minus 2, that is 2. Okay, so we have 3 situations here, okay, that would be possible for the conditions that we have given. Yes. 3, 4, 5, 6, 2, 4, 5, oh, sorry, one more over here, right, thank you. Okay, so I forgot to add up to 6, this one adds up to 6, this one doesn't. So therefore, there's one more left here. Okay. Any questions so far? Alright. Now going to the questions below, question 4. Using the Venn diagram, let's continue to answer. The number of elements of A intersect B is the largest when what situation? And the largest value of N, or largest value of A intersect B, okay, what is that going to be? Okay, so looking at the 3 situation, we're looking at A intersect B. So it is the largest when it entirely overlaps, which is a proper subset situation. That is 3, and we see B be a proper subset of A. Okay. Next, we want A union B to be the smallest. Okay. For A union B to be the smallest, that means there are things on the outside of the two circles. Okay. For the two circles to add up to be smallest, that means the outside must be a very big number. Okay, so comparing these three situations, that will mean that it has to be this one here. Because down here 3 plus 1 is 4, down here 2. As compared to this one is 2 plus 2 plus 1, that is 5, down here is 1. So we want the smallest one, which is 3 plus 1, 4. This one is not possible because it adds up to 6. So the value is 4, and that is when we have proper subsets. Then in part 3, we want the smallest value for A intersect B. Okay, what is that value and when does that happen? Let's find someone. Megan. Who is Megan? Yes. When does it happen and what is that value? The smallest value of A intersect B. Are you able to identify where is an A intersect B? Megan, you know what is A intersect B? Do you know what is A intersect B? Yes or no? It's okay to say no. You know what is A intercept B? Okay. Which one? This one. Okay, so A intercept B is the in-between. Okay, so we want the smallest value. So 1, 2 versus 3. 1 is the smallest one. So the smallest value is 1. And that happens when your A union B, okay, wait, hang on. Smallest when A union B is equal to A. A intersect B, smallest value. Sorry, let me just check the textbook.
It's so loud.
Okay, so we see that in this case here, okay, the smallest value is 1 for A intercept B, and that happens when your A union B, okay, is equals to your universal set, right? And then for the largest A union B, right? Okay, the largest A union B, looking at these situations, the largest one will actually be 6. When they all add up together, there's nothing on the outside. Okay? And that happens when your A union B equals to the universal set. Did I make any mistake over here? It's the smallest when A union B, smallest value. A intercept B is 1. A union largest. Yeah, Sorry, because when I prepared beforehand, right, which was months ago, I wrote something different. Okay, so I don't know what was going on in my brain back then. Okay, but I believe this is the correct answer. Right, nobody saw any mistakes, huh? We got 40 pairs of eyes over here. Okay, so don't be just a photocopier. You're not here to be a photocopier. Alright, okay, so with the understanding, whenever we are asked to find the largest and the smallest possible, we are always going to look at the possible Venn diagrams first. Okay, so I want us to practice this now. Okay, turn to your textbook page 24, practice now 11. Is there a way to freeze the image for this visualizer? Okay, let's look at question 1, yeah? For practice now 11. Okay, question says that the sets universal A and B satisfy the conditions of 23, 15 and 11 for the number of elements. We want to find the largest possible value of A union B complement. Okay. Are we at the question? Julia, have you fainted? Are you okay? Alright. So how do we go about drawing our Venn diagram for this situation? If you want, you can really go through all the possibilities, but you notice that you want to really go through all the possibilities, that can be very exhausting because the numbers are fairly large. There will be many possibilities. But never mind, let's look at extreme ends. So let's always start with the extreme, proper subsets and disjoint first. Look at whether it's even possible. So we have A and B, so A will be outside, B will be inside, because B is smaller than A. So it will look like this for A and B first. But the number of elements for the universal set is 23. At this point here, I only have 15. Therefore, I still have 8 left on the outside. So this is the proper subset situation on one extreme end. The other extreme end is your disjoint sets. We see that if I have disjoint sets 15 and 11, they add up to be 26. That already exceeds your universal set of size of 23, so not possible. Then now we go one step closer along the spectrum. We have the maximum overlap of 11. Since 0 is not possible, the other possibility that we can look at is where there's an overlap of 1. Because only an overlap of 0 not possible. So the next one before this happening is an overlap of 1. So A and B, universal. When there's an overlap of 1, that means that the number of elements in B, not in A, will have to be 10, and this is 14. We add that up, 14 plus 1 plus 10, that gives us 25, which is still bigger than 23. So, not possible. So down here, total elements is 25 more than 23. This one 26 more than 23. Okay? So if you are fast enough to catch on it, right, you need to keep in mind that the total for A union B has to be equals to 23. Okay? Then go at the end over there. The eyes closed already. I'm very certain it's not eyes small. You okay? Right? So let's go on. Okay, in between, how will it actually look like? Okay, we want it to be 23 in total. Okay, so can someone suggest to me what is actually possible in the overlap such that it will end up to be 23? What if it's 2? Okay, if you are not able to visualize it, never mind, we exhaust it. Okay, if it's 2, then the number that the value over here will be 11 minus 2, that's 9. 15 minus 2, 13. 13 plus 2, 15 plus 9, 24. Still not possible. Okay, so you can go and tweak it. We are expecting 3 then. Okay, that's why draw in pencil. This is just a working, you can draw in pencil, can erase. You don't need to go and show me all the different possibilities, yeah? Okay, because the question also never says so. Right? So if there's 3, that means over here I will have 8. Okay, and then over here I will have 12. Okay? Then that will add up to be 23 already. So I have a lot of things that are in between. Okay, fully overlap, okay, of 11 elements inside, the overlap, otherwise up to 3. So I can have an overlap of either 11, 10, 9, 8, 7, 6, 5, 4, 3. Okay, so I can expect to draw 9 different Venn diagrams, but no need to go and draw. Okay, you just draw the extreme ends can already. Disjoin, and then after that, the proper subsets. Okay, if disjoin cannot, then you work backwards. Right, to find the maximum overlap and the minimum overlap. You understand? Okay, so with these 2 Venn diagrams, actually we can go on and solve the question already. Okay, we want to find the largest possible value of A union B complement. Okay, sometimes seeing things in complement can be a bit difficult. Okay, depending on yourself. Okay, maybe you want to see expressed in this manner, or you want to see expressed as A complement intersect B complement, also okay. Right? So now, okay, what if you find that you want to stick with this one, A union B complement, and I want the largest one. Let me just put the largest. Okay, so A union B is actually everything, and when the complement, that means the things outside. Okay, that number you want it to be the biggest, and in this case we see that the number is biggest is 8. Okay, because down here is none. Alright, there's nothing outside, so the largest possibility is actually 8. Okay, I'm not sure about you, actually I will find it difficult to try to interpret this one. A complement, that means outside A, intersect with B complement. I find that a bit challenging, okay, to actually think through that and find out where is the shaded area. Okay, so that's why you can put into practice also the shading that you have already just learned. Okay, so A union B is everything, all the circles, and then on the outside. Okay, this is what I'm referring to for this Venn diagram. Otherwise, it is referring to this in this Venn diagram. Okay? Okay? So, as much as the overlap ranges from 11 to 3, the one on the outside will also range from 8 to 0. Okay? But since we want the largest, we don't need to exhaust all the Venn diagrams to be drawn. Right? So just these 2 is good enough. Next in part 2. Okay, we want the smallest possible value for A union B complement. Okay, so since we have already found out what is the largest, which we saw that it's outside for A union B complement, the smallest will actually be 0. Okay, any questions? Questions? Okay, let's move on to question 2, alright? Okay, in question 2, it reads that in the class of 36 students, 8 students enjoy reading comic books, 11 enjoy reading adventure storybooks. Okay, so let us maybe denote it with certain letters. Comic books, let it be C. Enjoy reading adventure storybooks, let it be A. Okay, so that will be how we label our sets. Part I, we want to find the largest possible number of students who enjoy reading comic books or adventure storybooks. Okay, so the challenge in this question is being able to translate, okay, the words that are actually being found here into your set notation, so that you know what exactly is the shaded area that we are looking at. Okay, we're looking for when we draw our Venn diagrams. Okay, so let's draw our Venn diagrams first. Okay, so again, our extreme ends, purple subsets first. Okay, so the question says that the number of elements in C is actually 8, and the number of elements in A is actually 11. So that means C must be inside of A. Okay, if I want to look at purple subsets. Okay, so that means 8 is inside over here. On the outside here, I will have 3, so that they add up to be 11. Since there's a total of 36 students, so 36 minus 11, that will give us 25. Okay? Then going on to the extreme ends, let me erase this. On the other extreme end, we were looking at disjoint sets. So A and C. Okay, number of elements in A is 11, C is 8. They add up to give us 19 only. So that means that I can have on the outside, right, 36 minus 19, that would give us 17. Okay. So these are our extreme ends. Okay. Fully overlap versus no overlap. If you want to visualize the entire spectrum, okay, you can draw something that's in between just to help yourself. Okay. You can have the overlap as well. There's an overlap of 8 over here. For here, maybe you can choose to have 7. Okay. Then A and C will have 1 over here, and 11 minus away 7, that will give us 4. Okay, and then on the outside I will have 24. Okay, so this is the full range of Venn diagrams that you can have. In fact, there will actually be 9 different Venn diagrams that you will be able to draw. Okay, from overlap of 8 all the way to overlap of 0. So 9 different Venn diagrams. Now let's look into breaking down the question, yeah? Okay, from the words itself. Part I says largest, okay, possible number, who enjoy reading comic books, which is C, or adventure storybooks, which is A. Okay, what we earlier on already understood is that when it says all, it means everything. It can either be here or here. So when we shape both the circles. In fact, the sign to use is the union sign. Okay? So all we relate it to union. And means that both of it must occur. That means it must be the intersection. You understand? This is a little bit of mathematical logic. So if you want a summary, okay, all we relate it to union and we relate it to intersection. Okay, so for example, in this part 3, okay, the word and we relate it to intersection. Okay, so in part I, what they are looking for is the largest number of elements in C union A. Okay. To have the largest C union A, that means on the outside it must be the smallest number, and that will actually be in this case whereby the outside is 17. Okay, so it will be 11 plus 8, that is 19. You understand? Questions? Okay. If you get what I'm trying to say, I want you to give it a try. Part 2, 3, 4, you do it yourself now. I give you 5 minutes to work on it. Okay, if you still cannot follow what I'm trying to say, please raise your hand. I'll come over to you. Okay? comic books or adventure storybooks. So they don't enjoy both. Okay? How do you illustrate that into set notation? Okay? So because of the idea of or, union, okay, do not enjoy reading comic books, so we understand it as complement of C. Because you like comic books, then it will just be C itself, right? Or, okay, but the thing is that English sentences, okay, how we read this is that the person also don't enjoy adventure storybooks. Okay, so or adventure complement. So that's what you can interpret it as. But we have already learned how to simplify set notation. So alternatively, you could think about it as number of elements in C intersect A complement also can. Right? Okay, the idea of factorization which we borrow from algebra. Right? So C intersect A itself, okay, we want the smallest in the outside of the intersection, okay, that will actually be, what would that be? That will be 17, this part here. Because C intersect A is nothing, and then we want the smallest one on the outside of it, which will be 17, yes. Yeah. Hang on now. Smallest. Yeah, I made a mistake again. Smallest possible number of students who do not enjoy reading comic books or adventure books. Don't enjoy this or adventure book. C intersect A. Correct, right? No? What do you get? C union A prime. Like that, huh? I also wrote this down, but wait, I'm a bit confused now. Do not enjoy. Oh yes, correct. Sorry, my very terrible mistake. Who do not enjoy either one of these, right? Okay, sorry, my bad. So they don't enjoy, so complement on the outside, either one of these, so C union A. Okay, so C union A is where they are either comic books or adventure story books, okay? The union of it they like, but then the complement of it they do not enjoy, so we put a complement side outside. So therefore we are looking at C intersect, C complement intersect A complement. Okay? Yeah, which explains why the answer is 17. Okay, then after that, let me just finish off the rest. Okay, so the largest possible for enjoying reading comic books and adventure story books, that will be 8. Okay, and then the smallest possible who enjoy reading adventure books but not comic books, that means they enjoy reading and adventure, enjoy A, and not comic books, so N intersect. Okay, and that will be equals to 3. Alright? Okay, could you please go back and then digest this a little? Okay, if still any problems, please raise it up tomorrow. I apologize for my mistakes today. Homework exercise 1D, 1, 6, 8, 16 and 17. Due on Wednesday, 10, Thursday. Is Thursday better? Oh yeah, Thursday HPA also Wednesday. Then Friday don't cheat me. Okay.